This lesson will be over equivalent ratios and rates. So here's a table. According to this table, 1 eraser costs 5 cents, 2 eraser costs 10 cents, 3 eraser costs 15 cents, and 4 eraser costs 20 cents. Make a prediction for the cost of 8 erasers. So if I look at this, I could extend my graph as such where you can see 1 eraser costs 5 cents, 2 eraser costs 10 cents, 3, 15, 4, 20. So 5 would be 25, 6 would be 30, 7 would be 35. So I predict 8 will be 40. So you can use a table or you can extend a graph to make predictions. So let's look at this. Describe the pattern in this graph. It costs $3 for 1 CD. So the cost is the dependent. It depends on the number of CDs you buy. $6 for 2 CDs, because here's 6 costs $6. 2 is for the CDs. $9 for 3 CDs. So if I describe the pattern, if I buy $12 for 4 CDs, that's my prediction for the next one. 4 for 12. 4 CDs for $12. So in this activity, students will be cup stacking. Cup stacking is you get a cup, and a cup, and you make a pyramid out of it. Cup, cup, cup. So you set it up, and then you have to break it down. So imagine there are 2 students who are cup stacking. So one student cup stack, and then another student cup stack after that person. And they took, let's just say, 12 seconds. And then we had Team B. They had 4 students, and they were cup stacking. And they cup stack, cup stack, cup stack. And let's just say it took 20 seconds. Did Team A and Team B stack the same seconds per student each time? Explain. So let's look at this. Before we look at the mathematics, let's try to make some predictions here. If 2 students stacked 12 seconds, that means each student took about 6 seconds. If there are 4 students in Team B and it took them 20 seconds, how long did it take each student? Per student, for every 1 student? About 5 seconds per student. Wow. Team B is faster than this one. So let's do the mathematics on this. Express the number of seconds a student as a rate in fraction form. So Team A, it was 12 seconds. For 2 students. Team B, I believe, was 20 seconds for 4 students. Now, use unit rates to determine if each pair of rates is equivalent. What do you notice? Again, unit rate is breaking it down for per unit. Each unit for 1 unit. So if we divide both of these numbers by 2, that would be 6 seconds per student, for each student for 1 student. If we divide both numbers by 4, the numerator and denominator by 4, that would be 5 seconds for every 1 student. Are they equivalent? Definitely not. No, they are not equivalent. So let's look at our next example. So there was another contest. Team A had 3 students, so they decided, you know what, we're going to change up our team and have 3 students and get different players. And it took them 12 seconds. Wow. Team B had 5 students, and it took them 20 seconds. Even better than the last time. Did Team A and Team B stack the same seconds per student each time? So before I do the mathematics, let's see if we can do it in our head. So we took there's 3 kids, 12 seconds. Would you like to draw a bar model? We could draw a bar model if that's what you are into. That means I draw a bar and I know there are 12 seconds. I need to break it down into 3 sections. Dot, dot. So how many seconds will go into each section? 4. So 4 seconds for every student. So we could do the same thing for the bar model for 20 seconds. And I break it down into 5 sections. 1, 2, 3, 4, 5. So how many seconds will go to each section? 4 also. So they are equivalent. They did it the same rate. So let's do the mathematics. Express the seconds and students as a rate in fraction form. So let's see. 12 seconds. So there's 12 seconds for 3 students. While in team B, I believe it was 20 seconds for 5 students. Oops. So let's try again. Next one. So its next question says, use unit rates to determine if each pair of rates is equivalent. So what can I divide the numerator and denominator by? By 3. So it's 4 seconds for every 1 student. What can I divide the 20 and 5 by? By 5. So it's also 4 seconds for every 1 student. So the question is, are they equivalent? They are. So team A and team B worked at the same speed of 4 seconds per student. So today's lesson is you're going to be given 2 fractions or 2 ratios, and you're going to tell me if they are equivalent. If so, it is called proportion. So we're really learning something called proportion, where 2 equivalent ratios are proportional. Proportion. So there are different ways to determine if 2 rates are equivalent. One way is by examining unit rates, because some of y'all like breaking things down into 1 unit. For example, you have 15 pounds. Someone loses 15 pounds in 5 weeks. If this person lost 3 pounds per week, each week or 1 week, while another person lost 12 pounds in 3 weeks. That person, if you break it down, lost 4 pounds each week. Are they equivalent? No. The second person, as you can tell, is losing weight at a faster rate than the first person. So let's look at our next example. At HEB, there are 49 flowers placed in 7 vases. If you want to, we could do a bar model where this bar equals 49 flowers and we break the bar into 7 sections. Or we don't have to. At Kroger's, they have 54 flowers in 9 vases. Are these pair of rates equivalent? Let's think about it. What can I divide the 49 and 7 by? By 7. So that would be 7, let's label these, flowers for every 1 vase. Per vase, each vase. For 54 flowers and 9 vases at Kroger's, I could divide both numbers by 9, and I would get 6 flowers for every 1 vase. So are they equivalent? Definitely not. Again, if you like, you could prefer the bar model. I could have broken down the 49 flowers into 7 sections. 1, 2, 3, 4, 5, 6, 7. And then, but divide by 7, there'll be 7 flowers in each vase. Or I could have done it 54 flowers and break it down into 9 sections, 6 flowers per vase. Hollister has 13 t-shirts placed in 3 boxes. Forever 21 has 26 t-shirts in 6 boxes. Are they equivalent? Let's think about it. Let me simplify this first. That would be 13 t-shirts in 3 boxes. I stop right there. They are equivalent. Or another way I could have done it is, how do you turn 13 t-shirts to 26 t-shirts? Times 2. So I multiply by the scale factor of 2. So this is the between. So I can multiply 2 between these two numbers. I've gotten this. So they are equivalent. So you may not like unit rates. I prefer scale factors. So scale factor is the number you multiply by. So which of these can you match? Which of these are not equivalent? 5 apples, 10 apples, 8 bags, 16 bags. So I have to be multiplying by 2. There are 3 kids in 7 rooms. If I have 8 kids, 21 rooms, I multiply by 3, and I don't think this is equivalent, because if I multiply by 3, this should be 9 kids. 10 kennels, there are 20 dogs. Is 50 kennels, 100 dogs equivalent to 10 kennels, 20 dogs? I multiply it by 5, and they are equivalent. So this one is not equivalent. So when earlier I said proportion. So why are we finding equivalent ratios or fractions or rates? It is called proportion. You're going to be hearing the word proportion a lot in your middle school and high school life. You're given 2 fractions. They're going to ask you, are they equal or not? And sometimes one of them will be missing a number. Can you find that missing number? So they make a proportion. So that they are equivalent. These fractions are equivalent. So for example, someone has 16 flowers for every 8 peppers. Is 4 tomatoes, 2 pepper equivalent? So I could multiply by 1/4 for those who like multiplying by fractions. 8 1 times 1/4 is 2. 16 1 times 1/4 is 4. So they are equivalent. Or I could divide by 4. Or remember, I could have done the within. How do you turn 16 tomatoes to 8 peppers? Divide by 2. How do you turn 4 tomatoes to 2 peppers? Divide by 2. So they are equivalent. So use scale factor to find an equivalent ratio. So it costs $9. 4 movie tickets cost $9. If I have $27, how many movies can I go? That's times 3. The scale factor is times 3. So I could go to 12 movies. That's an M. And this one, 3 girls wear 5 bows. If there are 25 bows keeping the same rate, I multiply by a scale factor of 5, so that's 15 girls. 3 cheerleaders jumped 25 times. How many cheerleaders jumped 100 times? I multiply by a scale factor of 4, so that's 12 cheerleaders. So now that we understand that a proportion is where 2 fractions, ratio, or rate are equivalent, let's use it in more real world. Paint is mixed 4-part blue to 5-part yellow. That means I put 5 drops of blue for every 5 yellow. Or I could say 8 blue, if I double the recipe, 8 blue for every 10 yellow. Or I could say 12 blue for 15 yellow. As you can tell, make a table. I could also make a graph and show you this in a graphical representation. How many parts of blue do I need if I use 15 part yellow? Oh, I kind of already did it right here. 12 blue. What if you don't like making tables? What scale factor could I multiply? I could have multiplied by the scale factor of 3. 4 times 3 is 12, so it's 12. How many parts of yellow do I need if I use 8 parts of blue? Oh, 10. Will 40 part blue and 25, let's see, 40, let's put it right here. Will 40 parts blue and 25 parts yellow fit the pattern above? How do you turn 4 blue to 40 times 10? So 5 times 10 is 50. Definitely not. There should be 50 yellow. So that definitely does not. But first of all, I can just stop. That doesn't even make sense. Aren't there more blue? Aren't there less blue than yellow? So why is this blue bigger than the yellow? So it doesn't even make sense. So here's our last question. You can buy 3 medium pizza at the pizza place for $12 or 5 medium pizzas for $30. Do these rates form a proportion? That means, are they equivalent? So 3 pizza for $12 and the other place costs 5 pizza for $30. Are they equivalent? Let's see. I'm going to do a within. How do you turn 3 pizza to $12 times 4? How do you turn 5 pizza to 30 times 6? Are they equivalent? No, they will not make a proportion. Or you could simplify 3 pizza $12. That would be 1 pizza for $4. And if I simplify it as 1 pizza for $6. So are they equivalent? No. So today's lesson was over. Given two fractions, ratio, or rate, are they proportional? Do they make a proportion? Are they equivalent?